Welcome back to my channel, everyone. Sri Tips here, and we kind of hit a big load this weekend. I think I spent $1,100. Mrs. Sri Tips spent $1,100 plus $350, and then we both spent $19,000 on a mother load of carat scrap jewelry here. And so what we're going to do is we're going to go through all this stuff, clean it up the best we can, and well, what's that equal? About, let's see, 11 on 11 is 22, plus 19 is 21.2, plus 300, say $21,500 on this stuff. And so we're gonna go through and refine it, see exactly what it is that we've got here, and see if we can come out on top. Here I'm removing the stones, the springs, and all non-gold material from the carat scrap before we go to the next step. Got everything sorted out down here, and I got a couple of pieces that we're gonna try to sell online. This is a lady's 18K gold watch with 18K gold band, and I think this thing weighs about like 18 grams or something like that. I'm gonna check these out. These might be black opal, set in gold with diamonds. I've got a 14K gold pocket watch here. That's 14K. And Miss Sri Tips picked that up for $5. And the movement's not running, so we're gonna try to maybe do a small repair on that. Let's see what we got for weight on this stuff. I've sorted it according to carat over here. This is all our 14K stuff right here. Quite a bit. Let's put a weigh boat on, zero the scale. Let's see what we got for 14K material. Looks like 341.5 grams of 14K. This is an app called Kitco Scrap It. According to this app, 341.5 grams at 100% of spot. What's spot gold at right now? 33.6150. 100%. That's $21,528 for this gold. Get the 10K stuff weighed up here. Zero the scale. This is our 10K material. Here. Looks like we've got 87.3 grams of 10K. This will be our profit right here, not counting the watch and the other earrings over there. 87.3 grams of 10K is going to be $3,931. Let's take this off of here, zero the scale out, put our 18K gold watch up here. I think I took off a few grams for the movement and called that 18.7 grams of 18K. Take this watch off here. I'm going to measure the 14K gold pocket watch case. That's 19 grams. And I've already got all these figures, these three figures here, totaled up, $26,974 for this gold that we've got so far. That's 19 grams of 14K. Let's go ahead and put that in there. That's going to be $11.97. for the 19 grams of 14K for this watch. So let's add that in, plus, what did I say it was? $11.97. 1197. Grand total for all the gold that we bought will be $28,171. I've got everything separated now in these two bags. This is 10K, this is 14K. Plus I have a little bit more 14K stuff here that we're going to be adding. So what we'll do is put our little container up here, zero this out. This will be our 14K material. I'm going to dump this in, see what we got here. It looks like 359.2. I'm going to add this in. This is some more stuff that we got here. So it looks like we got 391.5 grams of 14K. 391.5 grams of 14K. Let's pull this down now, get it out of the way. Here's our 10K bin. Zero this out. This is our 10K material. And that's gonna be 86.6 grams of 10K. I'm not very proficient at refining large batches like this. It's been a while since I've done that. And the reason I do this, there's several reasons. The first reason is because I love it. The second reason is to make videos for my YouTube channel. Third reason is this gold will contain platinum group metals and silver. And when you send this in to sell it to a big refiner, they don't give credit for the platinum group metals or silver, and I get to keep that if I refine it myself. And the last reason is because when I get done refining this material, then what I'll have is a piece of gold that looks similar to this when I get done. And this, when I send this in to sell it, if I sell it, then what'll happen is there's no room for the buyer to fudge because it's pure gold. Now we need to determine how much sterling silver to add. We're going to use these constants. These are numbers that we use every time for this weight of 14K gold, and it will give us the proper amount of sterling silver to be able to inquart this gold properly. 391.5 times 1.265 equals 495.2 grams of sterling silver. For the 10K, it's going to be 86.6 times 0.635, and that's going to be 54, we'll call it 54.9, we'll call it 55 grams of sterling silver. Okay, I've determined that I need about 550 grams of sterling silver. I had 0.2 up here. That's insignificant, so I just disregarded the decimal, anything after the decimal. So we're going to measure out 550. Let's see what we got here. There's 503. 530. That's 568. I think we'll be okay with that amount of sterling silver to inquart this amount of gold. Okay, let's gather up our metal. I'm going to head outside and inquart this gold with this sterling silver. Before I can do the incortation, I'm gonna have to coat this melt dish with some borax. It's important to coat the melt dish with borax before we try to melt any metal in it, to prevent the metal from sticking to the insides of the melt dish, and the borax coating will help the molten metal flow down into a central mass in the bottom of the melt dish. During this process, it's important to have that water very cold. I use 3 trays of ice and then 4 big chunks of ice in there. It's so cold if you stuck your hand in there, it kind of hurts. And the reason for that is because if we tried to do this in just ambient temperature, room temperature water without the ice, that molten gold will stay molten as it travels through the water, and it will tend to clump together and not form individual pieces like it's doing here with the water being ice cold. Here's the incorted gold. Now that we've alloyed enough silver with it to get the gold content down in here to about 25% pure gold, we can now use hot dilute nitric acid to start pulling all the silver and all the base metals out of the karat gold. I'm going to go ahead and add some dilute nitric to this right now. Another jar of it that I saved from a previous refining. Go ahead and add this right on in. Let's wait for that reaction to calm down a little bit maybe first. It's been a while since I've refined this much gold at one time, and when you don't do it for a long time like that, you lose proficiency. You can add a little bit more nitric in here now. Set this up on some heat. Oh yeah, it's already got quite a bit of heat going on just from that reaction. This is the first nitric acid boil. I got to be careful and add the nitric acid in there slowly. Otherwise, I may experience a boil over. I think this first nitric boil is complete. Adding some distilled water because I don't want to set that beaker on a hot plate without any liquid in it. Adding some more nitric acid. I can tell our second nitric acid boil is complete because the fume production in there has ceased. So now let's go ahead and pour off the second nitric acid boil. What we're doing here is removing all the silver and the base metals out of here. With these nitric acid boils, the gold gets left behind. It will not dissolve. And so we're separating the metals, the silver and the base metals, from the gold by doing these nitric acid boils. You can see the silver forming in there. See that? On the inside of the hot beaker. That's silver nitrate forming in there. Water in here because I do not want to set a dry beaker on that heat. It'll crack it. I've had that happen before. Here's our dilute nitric that we prepared earlier. 50-50 dilute nitric, distilled water and nitric acid. I'm going to add this in now. I've got a new hot plate that I'm using there, and I could not get that thing to get hot enough. I had it turned all the way up to high, and it wasn't heating up enough to cause the solution to boil. So I swapped it out with a different hot plate. Got just about all we're going to get out of this nitric acid boil. So we're going to go ahead and pour this off now. That blue liquid I'm pouring off will be full of silver, and I can tell there's not very much nitric left in there. It's been all used up by this reaction because there's lack of fumes when I pour it over that silver. Add a little bit more nitric acid to this. I'm going to keep doing this until the solution in here remains colorless. And what that'll do is that'll let us know that we've got all of the silver and all the base metals pulled out of the gold. The gold will not dissolve, it gets left behind. Here you can tell by the amount of fumes being produced that there's still lots of silver and lots of base metals that are being pulled out of the incorted gold with these hot dilute nitric boils. I think we've got just about all we're going to get out of this nitric boil. let's go ahead, pour this off now, carefully. Notice that there's a vigorous reaction with the silver in the silver jar now as I pour off this blue liquid. That's what the silver in that silver jar is for, to consume the excess nitric that's being poured off from the incorted gold. There's a lot of excess nitric in there because as this reaction progresses, the nitric that's in there loses its potency and can no longer penetrate. Some of this off into a separate jar here so we don't overflow it. There's lots of silver, lots of liquid, and lots of free nitric in that liquid. And everything's hot, so I'm pouring some of it off into a separate jar so that it doesn't overflow on me. Nitric acid now, and keep going until we get a colorless solution. And when we get that condition, then we know we've got the silver and the base metals pulled out of here. Incorting with silver and then pulling the silver and the base metals out with these hot dilute nitric boils, it's a very effective technique at removing all the silver and all the base metals from the karat gold. When I get done with this process, in fact, there will be just more or less pure gold left when I'm done with these nitric boils. Notice I poured just a little bit of the hot nitric into the rear jar there because it's full of silver. This front jar has very little silver in it, so I'm pouring off most of the blue liquid into that front jar. There's going to be quite a bit of excess nitric left in these boils that I'm pouring off because now that the reaction is nearing completion, there's going to be excess active nitric acid in that liquid. Allowed this to cool completely, and I think that now that we've got most of the silver out of this incorted gold, I'm going to transfer it to a smaller beaker so that it's easier to handle. Always one little group that just likes to hang on and not come out of that beaker, man. A couple of little bitty pieces. Never fails. Look at him. He's hanging on up there, man. No matter how. Don't worry about it, Kev. We're good. I will set this back up on the heat and continue doing nitric acid boils. Like the gold is starting to come apart just a little bit. That's what it looks like down in there. Most of the silver and the base metals have been removed now. we're going to add a little bit more nitric acid here and see if we can get the rest of the silver and the base metals out of there now before we go to refine it with Aqua Regia. You see there's a little bit of fumes going on up in there. The color of the solution is still blue. This thing is just banging away out here from the water hammer. I'm going to turn the heat off and let this cool down. This blue color in here means we're still pulling some copper. And if we're pulling copper, there's a good chance we're probably still pulling silver also. So I'm going to pour this off into a container down here and save it. There's lots of free nitric acid in that liquid that I'm pouring off. I'm going to save it and we can use it in a future video to pull silver and base metals out of incorted gold. Before I go to the next step, I've got some sand, and someone suggested doing this, just coating the bottom of our heating dish here with some sand. So I'm going to try this and see if it'll prevent that that steam bubble hammering that I'm getting when I heat up the liquid in this container. See if this will disperse the heat for us. I'm adding some distilled water. I'm going to boil the gold in a little bit of distilled water. And now we're going to see if our experiment is going to work with the sand under there. Add a little bit of heat. And let's see if we can boil this without blowing the beaker up. Here you can see after the beaker heated up that it started dancing around on a hot plate, so it was still producing those steam explosions. Still getting lots of steam explosions in here. I'm going to let this cool off and then we'll get the water out of there. Let's get rid of this water out of here. Do is put this back up on the heating pad. Add some more distilled water, just a touch. Now another nitric acid boil. Try to keep the heat down low and keep those steam explosions minimum. Been on here boiling now for quite some time, and I think the batteries in my watch back here are starting to fail because the time isn't correct on that. But you can see here that our solution just barely got a little bit of blue color to it. And I think we're going to be good with this. So we're going to set it down here and let it cool off. I'm going to pour off this nitric. We'll save this nitric acid in here. Adding some distilled water. And what we're going to do now is just set it up here on some low heat just let it soak in some hot water. If you look down in the gold, you'll see something sitting right there on top that does not look like gold. I think it may be a piece of platinum, maybe a platinum ring that's snuck in there, disguised as white gold. But what we're going to do is we're going to pull this down off the heat. See it in there? Something, not sure what it is. And I'm going to reach down in there and try to get this out of there before we start the refining process. Just going to get it out of there. This water off out of this beaker with our gold in it. That's just some distilled water that we had the gold soaking in. We're ready to refine it. The recovery process is complete. We're ready to refine this gold. This is almost 8 troy ounces of pure gold that we'll be refining. So I'm going to transfer it out of this small beaker. There's our gold. The gold right there, just like it is very close to 3/9 without any further refining. But in order to get it to 3/9, we're going to have to refine it with Aqua regia. So I'm going to transfer it into this big beaker here. I've got some hydrochloric acid in a bottle. We're going to rinse the gold out of our beaker with some hydrochloric acid. I'm adding hydrochloric acid into the gold. I'm going to fill it up to about the 1 liter level, because that's about 8 troy ounces. And I want to make sure I've got enough hydrochloric acid in here to get everything to dissolve. Cover this up. As usual, we'll add a little bit of sulfuric acid. And what this will do, this will precipitate out any lead that may be present in our gold. Let's set this up on our heat source back here, and we'll pull this up so that we can get a good shot of this gold going into solution. Just want to point out that I've got our little clock. I put a new battery in this thing so we can pull this down and keep track of time. Hydrochloric acid to rinse the stuff off the inside of the beaker. For this reaction, I'm thinking maybe about 20 milliliters per troy ounce of pure gold. So I'm going to measure out about 125 milliliters of nitric acid in this container, and then we're going to measure out about 50 milliliters in this one. Now what I'll do is put this on time lapse, and I'll add this 50 milliliters of nitric in to begin the reaction, and then we'll add small amounts with this dropper out of this container into the beaker as we progress through the reaction. I'm going to try to get all this gold to go into solution. There we go. I'm going to put it on time lapse to do that right now. A couple of factors affected this reaction. Number one is my lack of proficiency at dissolving this much gold. And number two is the solution was dark, so I could not see what was going on in there. And I ended up putting about 125 milliliters of nitric when 75 or 80 probably would have done it. I think I've got all the excess nitric driven off of this solution. So now we'll go ahead and turn the heat off. Let this cool down a little bit. We're going to cool this down with some ice. It's already been allowed to cool down significantly for a few minutes, so it's not that hot in here. Got in the filter. Some kind of sediment. I don't know what that is. I'm just going to set this back out of the way for right now. Transfer our solution into a clean beaker. I've got some ice in here. Whenever I have 2 or more troy ounces of gold to precipitate, I always add some ice so that we can keep it cool. It's a very exothermic reaction. I'm going to add some sodium metabisulfite, which is stump out by bonide. I'll go ahead and put the first spoon in. It should take about maybe 8 or 10 spoons. There's the first one right there. Two. Three. Four. 5. 6, 7, and 8 spoons of sodium metabisulfite. In here and do a Stannis test and see if we've got all the gold to precipitate yet or not. And as you can see, we've still got gold in solution, quite a bit of it. I'm going to add a couple of more chunks of ice, try to keep it cool. And we're going to put in some more stump out, try to get the rest of that gold to precipitate. There we go. stir. I think I still see some yellow color. Gonna reach in here and do another Stannis test. See if we've got all this gold to precipitate yet. I don't see no color on there, so I think we've got it. I think we've got all the gold to precipitate. Let's cover this up and let it settle out. I still see a little yellow color in here. Here's our test strips indicating we've probably got some platinum in this solution with the gold. I've allowed this gold to settle out for about half an hour or so. You can tell by the color in here, there's some platinum group metals in this solution. So rather than pouring it off into my temporary waste container, I've got one of my stock pots right here. The stock pot has pieces of copper in it, and then the residual platinum group metals and gold that might still be in there. We'll cement out onto this copper. So we're just going to go ahead and pour it right on in to the stock pot, this green liquid. It's going to be platinum and palladium probably in there. Successfully. Alright, this happens sometimes when you're precipitating this much gold. It wants to try to go back in solution on you. Let's see what we got here. Look at all that, man. That's all gold that's come back out, or come back out of a solid back into solution. I'm going to add some hydrochloric acid. Give this a stir. A little bit of distilled water. Give it some more SMB and see if we can get the rest of it to precipitate out. There it goes. Give it a little stir here. See if we got all the gold out of there now. I think we've got it all now. Might still be a trace of some platinum group metals in there, but I think we've got all the gold precipitated. Yeah, I think we've got everything out of there now. Allowed this to settle overnight, and what we're going to do is reach in here and see it's got some color going on. Get a little bit of it on a piece of filter paper. Let's see what we got in here. I do see a little bit of a color change on this piece of filter paper. If you look at that, you can see that there's an orange color going on, and that indicates that we've got a little bit of platinum in this solution sitting on top of our gold. What I'd normally do is pour this waste solution off into my temporary waste container, but I don't want all this platinum going into the temporary waste container, so we're just going to add this directly into my stock pot over here. I've got some hot distilled water, and I'll rinse the gold over and over with this hot distilled water. I didn't anticipate a bunch of platinum being in with the gold, and so what I'm doing here is rinsing it over and over and pouring off those rinses directly into the stock pot. And a little bit of gold is going to get poured over with it. It won't be much, but everything that goes into the stock pot, we can recover that later on when we process the stock pot for the precious metals that it contains. I should have most of that platinum rinsed off of the gold now. Plus, these rinses will rinse off any residual sodium metabisulfite that remains in there. Add a little hydrochloric acid. I'm rinsing the gold powder with a little bit of hydrochloric acid before we go to the next step. I'm done with this. Let me get this out of the way. Set it outdoors because it's going to emit fumes. I'm going to add about, let's go with up to the 800 milliliter level this time. Now we better go a little higher than that. Let's go to 1 liter because that's quite a bit of gold we're going to be dissolving again. All right, let's move this up on our heat source over here. What we'll do is add the rest of this nitric from the first refining. We'll add that right on in, and then once I get that in there and get the reaction going, I'll add small doses of nitric from this bottle with this dropper, and we'll try to do a little bit better job at regulating the amount of nitric acid that goes into this reaction. I'm going to add a little bit of sulfuric acid, and what this will do is this will precipitate out any lead that may have made it this far into the process. Let's add some heat, just a little bit, not much. Now what we'll do is I'm going to put that thing on time lapse, and we'll add this, about 40 milliliters of nitric acid, and start the reaction. Here we go. Here we go. We're going to start the reaction. I add the 40 milliliters of nitric acid, and then every time you see the little bottle of nitric pop up on a screen there, that's me adding about 3 to 6 milliliters of nitric acid into the reaction beaker. We've got most of the gold dissolved, and now what I'm doing is adding just 1 milliliter or maybe a half a milliliter of nitric acid towards the end here, so that we can control the amount of nitric going in, so we don't have a whole bunch of excess nitric once this reaction is complete. Got our beautiful orange chloroauric acid solution here. What we'll do is just pull this down off the heat now and let it cool down. Got everything pulled through the filter, and you can look here, and there was a little bit of stuff in our filter, so it's a good thing we filtered it. Now we're going to move this out of the way and get ready for our next evolution. We've got a gas generator set up back here. I've got some sulfuric acid in this addition funnel. I've got sodium metabisulfite slurry down inside of the gas generator. And the gas is going to come out of this tube, circle around, and go in the top of this bubbler over here, which is full of sulfuric acid. And then the gas, SO2 gas, will come out of here, follow this tube around to this delivery tube, which goes into our reaction vessel. Let's turn this beaker so we can watch the reaction unimpeded. We're going to start dripping some sulfuric acid down into this SMB and establish a flow of SO2 gas through our gas generator. There we go, we got a gas flow. All right, I've never tried a batch this big. This is about 8 troy ounces of pure gold. We're gonna add this gold bearing solution now into our big beaker here. I'm adding a gallon of distilled water because this reaction happens best when our solution is diluted. We're all set. We've got a gas flow established. And we're going to go ahead and put our delivery tube in here now. Start bubbling SO2 gas to our chloroauric acid solution. starting to form some gold on the surface of the gold-bearing solution. See if I can ramp up the gas flow, add a little bit more acid to our gas generator, and see if we can get this stuff to precipitate out of here for us. Some little bits of metallic gold forming down there. This is about 8 troy ounces of gold. I'm going to add a little bit more water. I want to make sure this solution is very dilute, because this reaction happens much better from a dilute solution. Yeah, now we're starting to get a real pretty crystal reaction going on in there. Wow, look at that. That is gorgeous. Slow the gas flow down just a little bit here. I'm going to reach in here with a piece of filter paper and see if we still got any gold in solution. We do. So we'll continue bubbling gas until we get a negative Stannis test on this. Gas generator has become expended. Reach in and get another Stannis test, see where we're at with this. Just a faint bit of a stain. So we'll keep trying to bubble this gas as long as we can until we get all that gold to precipitate. got it. I think we've got it all precipitated now. Okay, I lucked out because I put what I thought was going to be an excess of SMB in there, but it turned out to be the exact right amount. Let's get this delivery tube out of here. All that's left to do now is wait until this settles completely, and then we're going to go in here and get our gold out of here. It's already started to settle out. Looks like it's settling out real good. We'll put this on time lapse and let it settle completely. I've got this settled good enough, I believe. So now what we're going to do is pour this waste solution off into a waste container. Looks like we had a bunch of undissolved gold in here that precipitated out in our waste container. I'm going to get this out of the way now. Gonna rinse the gold over and over with hot distilled water. Gonna try some hydrochloric acid on our gold, see if we can rinse it off with a little bit of that. Trying to boil this gold. Some hydrochloric acid. This is looking real good down here now. And what I'm going to do is try dropping a few grains of SMB down in here. See if this gold will precipitate. Here we go. Gonna put a little spoon of it in, half a spoon. See what happens. Here we go. Oh yeah, look at that. That's gold in there. That's good. That's my savings account in that temporary waste container. So we'll just let that build up. The gold back there is boiling in hydrochloric acid. It looks real good. Now we're going to rinse all the acid off with some boiling distilled water. Get this gold into a drying dish. I've got 107.0 grams for the weight on the dish. Got the gold powder dried off completely. Gonna kill the heat, let this cool down. Here's our dried off pure gold powder. Looks spectacular. I think what we're going to do is we're going to transfer it into this covered dish. This thing weighs 404.2. 404.2 grams. We're expecting 246.3 grams from this amount of material that we're refining. Let's tear this scale down to 0. And now we're going to transfer our gold powder into this container. Alright, looks like we've got 251.2, and we were only expecting 246.3. So we may have had some higher carat stuff than we had accounted for in that group. Well, it's always good to have more than you were expecting. Nice, beautiful, cinnamon colored pure gold powder, 3/9 fine. I'm going to put it in this container for right now until we figure out what we want to do with this stuff. In here before I start heating things up. Look at this gorgeous, gorgeous bar of pure gold. Man, that thing's nice. It's just absolutely stunning to look at it. Look at that reflection there. And let's see, what were we after here? We were looking for 246.3 grams of pure gold. Now that we've got it melted, let's see what we got here. We've got 250.8. That's a little less than one we had earlier, but I mean, it's we're gonna take it, man. That's absolutely, I'm happy with this. I'm glad it's over. I do not like working with large amounts of gold like this. It's very cumbersome and kind of nerve-wracking. So I'm glad this refining is complete. All right, this will conclude the video. I'd like to thank everyone for watching.